Hi, everyone. Thank you for joining me today for this talk on microbiome and mood, navigating in the world of psychobiotics. I am Dr. Michelle Maddox, the clinical consultant for Omni-Biotic, and it's a pleasure being with you today. Let's take a couple of minutes to review our agenda for this talk. We will have a very quick terminology review, make sure we're all on the same page. We will look at the scope of the problem. We'll review the microbiome gut-brain axis and establish the state of the literature regarding psychobiotics in the clinical setting. And then finally, we'll spend just a small amount of time looking at strategies for selecting a quality probiotic so that we can do the best for our patients and help them understand why we're recommending one over another. I am going to call attention to the diagram here on this side. This is based off of Edward de Bono's 6 thinking hats, and I like to think about these as I'm learning new concepts or perhaps establishing a new view of a concept that I already had, because it reminds me to focus on things like gathering the facts and maintaining a healthy amount of skepticism. What does my gut tell me? Thinking critically, etc. So again, we'll start off first with a bit of a definition overview to make sure that we all understand what the terms that we're using today mean. But first, we're going to look at some pictures. My favorite is this one on the bottom left from Psychology Today. We have seen this huge surge in the microbiome and gut-brain axis and so on and so forth. It's everywhere. And these little cartoons, I just love. They're so clever. We even are seeing it in veterinary medicine, which is pretty amazing. So the picture on the far left, it's the microbiota. And microbiota, it's the organisms, and that's all, just looking at the organisms. The metagenome, these are the genes and the genomes of the population, both the bug and the host. And again, genome are the sum total of organisms' DNA. So it's everybody's, the bugs and the host DNA. Microbiome, now we're looking at the whole soup. We're looking at the gene, the genomes, and the products of that population for, again, both the bug and the host. This is going beyond just the bugs that are there into what they're actually doing. This is that metabolomics. We're going to take a moment to define strain. I know for a lot of us, basic biology was a very long time ago, and I never learned what a strain was. It just wasn't really a thing. And so we'll review that. Most of us learned some version of King's Play Chess on fine-grained sand, and that's kingdom, phyla, class, family, genus, species. You'll notice there's no strain here. A strain is isolated from a species, and it's distinguished by the genotypic and or the phenotypic characteristics. And specific strains are then tested for specific and targeted outcomes. So what is a probiotic? A probiotic is alive microorganisms that, when administered in adequate amounts, confer a health benefit on the host. You'll notice that the graphic starts with strain. It has been characterized, and we'll look at that phrase and what characterization means a little bit later. Is it safe for consumption? Have there been clinical studies, preferably at least one of them has to be in a human? And does it have shelf life stability? And is the shelf life stability on the amount that was shown in that human study to be effective for what they're promising? So now, what is a psychobiotic? Probiotics that confer mental health benefits to the host when ingested in a particular quantity through interaction with commensal gut bacteria. So commensals, I always like to think of them as community. right? You've got all sorts of different things coming into your community, and a good, healthy community has a diverse population. When that community starts to skew into having an overgrowth of any particular microbe, now we start to have problems. And so the commensal is the community and everything is in balance. There's a really good diagram here to show you the different steps that a psychobiotic goes through in its evaluation. Now that we've established that we're all speaking the same kind of basic language, let's look at the scope of the problem in regards to numbers and how depression is predominantly handled. So depression was an issue long before the pandemic hit. However, overall depression rates have tripled since early 2020, and the number of people who met criteria for depression increased 5% across all age groups, and 18 to 60-year-old plus was measured. 44% of 18 to 39-year-olds met criteria for depression in 2021. The percent of people meeting criteria for depression significantly more elevated in lower income households and for those with less than $5,000 in savings. The part of this that's incredibly scary for me is how much younger the predominantly depressed population has become. So what causes depression? There are really quite a few theories. Serotonin and or norepinephrine availability and or receptor function, genetics, adverse life events like trauma, hormone imbalance, not just sex hormones, but also things like cortisol. And finally, oxidative stress and inflammation. One study showed earlier onset of depression and a higher likelihood of relapse in those with elevated CRP, but not elevated TNF-alpha. Which leads me to this quote. More importantly, depression is not a single gene disease, but rather seems to be related to multiple genes in interaction with environmental factors, which lead to a spectrum of adverse outcomes, ranging from depressive symptoms to full-blown MDD. This suggests that MDD may be a more heterogeneous disorder, both in etiology and pathophysiology. This is basically a very wordy way of saying it's more complicated than we originally thought. I love this picture. What this little picture says at the bottom is alcohol can relieve symptoms of social phobia, but it does not mean that alcohol corrects a chemical imbalance underlying social phobia. The medical concept of depression obscures the diversity of problems and experiences that come to be labeled as depression. And the social explanations and interventions have been highly undervalued. I want to be very, very clear in saying that I believe there is a time and a place for antidepressant medications, and there is no shame whatsoever in taking them when they are needed. I had very severe postpartum depression after the birth of my second son, and I truly believe that without the antidepressant in that moment, I would not have been able to form the bond with him that I did, which developed into the beautiful relationship that he and I have today. There is definitely a time and a place and no shame in taking the medication when you need it. However, what I am saying is that treating depression cannot end with the prescription. Antidepressant prescriptions have been steadily increasing every year. 13% of those 18 plus take them as of 2019. We know that's gone up. 24% of women over 60 take medication for depression. Despite the increasing usage of medication, we know that rates of depression are up. We know that the duration of depression is increasing, and suicide is the second leading cause of death in 18 to 34-year-olds and really scary 10 to 14-year-olds. And while there's definitely an aspect of being more open about depression than there used to be, which is potentially contributing to these increases in numbers, I do believe that there is still a gross underreporting because there is a stigma around depression, especially in certain communities and demographics. Depression and mental health is still very much not talked about. So, how do you measure efficacy when you are treating depression? One of the best tools that we have for measuring subjective data in an objective way are questionnaires. The PHQs, HAM-As, HAM-Ds, PANAS, LEADS, BDI, etc. All of these are examples of questionnaires that are readily available. They have been vetted. There are studies showing their efficacy and accuracy, and they are very helpful in assessing the current state and then using them periodically to assess improvements in depression and anxiety. Additionally, lab tests that are not typically used to evaluate improvements in depression should be also considered. So things like inflammatory markers, CRP, hsCRP, and interleukin 6, etc. Hormones like cortisol, thyroid hormones, DHEA, and other sex hormones. And then as well as oxidative stress markers, glutathione, total antioxidant capacity, superoxide dismutase, etc. Here we see the DSM-5 criteria for diagnosing depression. The criteria for diagnosing major depression is 5 or more during the same 2-week period that are a change from previous functioning. 2 to 4 are considered minor. Obviously, this is already going to be somewhat problematic if the person has been depressed for their entire life, right? Because this isn't a change for them, it's how they always are. There must be either an A1 or an A2, so either depressed mood or a loss of interest or pleasure in activities for a diagnosis of depression. And in addition, things like changes in sleep, ability to think, psychomotor changes, appetite changes, etc. So in addition to the standard diagnostic symptoms, depression has been associated with a number of other conditions, sometimes as an understandable consequence of the condition, take cancer, for example, and other times as a side effect of the medication or the treatment or the limits and impacts the condition has on their quality of life. So things like asthma, diabetes, arthritis, COPD, etc. We also see depression with somewhat less obvious associations. The column on the right was from a paper focusing on depression in younger populations. And in that particular population especially, there was a lot of negative social cognition, self-blame, low self-evaluation, negative expectations of themselves, negative expectations of life and others, disgust, anger, etc. As this is a talk about the gut microbiome, let's look a little bit at the changes in the gut microbiome seen in depression. We see a lowered diversity. So diversity is the variance in the organisms. So how many different kinds of organisms are in the microbiome? When that variance goes down, that's a lower diversity. And then we also see a lower overall number of microbes. So the actual number of the species goes down. So for example, there are fewer lactobacillus than there should be. Short-chain fatty acids become skewed. Short-chain fatty acids are created by microbes acting on resistant starch, otherwise known as fiber. We know that the balance of the main ones, the butyrate, propionate, and acetate, shift away from predominantly butyrate, which is widely considered to be one of the most important and vital for a healthy gut lining. Alterations in the gut microbiome also alters how our body processes and metabolizes certain pharmaceuticals. So for example, Rhinococcus flavifaciens metabolizes fluoxetine, and it inhibits its mood affecting ability. This is a really, really good visual. I am a highly visual person, so I try to throw a bunch of visuals into my presentations because I know I'm not the only one who's out there. Notice that this is a feed-forward and circular loop in many instances between the microbiome and depression, with arrows pointing in both directions between the brain and the gut microbiome, the brain, the gut microbiome, and the circulatory system, and the brain, the gut microbiome, and the adrenals. So you end up with depression triggering alterations in the gut microbiome, which triggers alterations in permeability, which trigger alterations in inflammation, which trigger alterations in cytokines, which trigger alterations in adrenal output, which trigger alterations in brain chemical balance. And all of the varying permutations and intersections in between these reactions. This is a really good picture. I think that it helps people visualize dietary impact on the gut microbiome. It's fabulous to use with patients. And so on the left-hand side, you see the standard American diet, right? Lots of processed foods, lots of simple carbohydrates. And what we see is that the bugs in the gut are quite skewed. There's an increase in firmicutes, and then Prevotella, Bacteroidetes, and Akkermansia all go down. This skewing results in an increase in cytokines, lipopolysaccharides, etc., and it leads to inflammation. For a predominantly meat-driven diet, right? I'm not making a comment about diets in general, but what we see is with a diet that is very high in meat, the skewing that happens in the gut microbiome is the Enterobacteriaceae go up, Ruminococcus goes up, Roseburia goes down, and Fecalibacterium go down. Then we see things like TMAO, which has been strongly associated with cardiovascular disease, go up. In a diet that is nice and high in fiber, now we see things like Prevotella, Bifidobacter, Eubacterium, Roseburia, Fecalibacterium, all of those things are nice and robust. We get a good, healthy balance of short-chain fatty acids, and we see that these are anti-anxiety and anti-inflammatory. Given that this is a talk on psychobiotics, or gut microbes that are specifically targeted to mood, let's spend a little bit more time diving into the MGB, or the microbiome gut-brain axis. First and foremost, we know that our microbiome is responsible for digestion and metabolism. We've known this for a ton of years. We know that it has duties that are degradation of insoluble dietary fibers, protein degradation and fermentation, bile acid deconjugations. It helps with synthesis of vitamins. It regulates appetite and bowel regularity, and it has the ability to activate certain medications. The gut microbiome is the reason that women who are on oral birth control pills are told to use alternate forms of birth control when they're on antibiotics. Those pills rely on a healthy gut microbiome to be activated. The antibiotics kill the healthy gut microbiome, and now they're not activated. Central to this microbiome gut-brain axis is the vagus nerve. It is a bidirectional nerve, so it is efferent and afferent. Efferent, from brain to gut, is approximately 10 to 20% of its fibers. And the splenic sympathetic anti-inflammatory pathway and the cholinergic anti-inflammatory pathway are mediated via these vagal efferent fibers. We have the splenic sympathetic nerve stimulated by the vagus nerve, releases norepinephrine, noradrenaline, which then triggers the release of acetylcholine. ACH binds to receptors to inhibit TNF-alpha locally. This pathway is commonly triggered by pathogenic organisms, and it's being really heavily studied in the treatment of IBD. The afferent pathway goes from the gut to the brain, and it is approximately 80 to 90% of the fibers. These are responsible for adaptation to stressors of any kind. You really do get a gut feeling. Triggering alterations in corticotropin releasing factor, which is CRF, which triggers ACTH, which triggers cortisol release. Another example is the hormone ghrelin released from the stomach. It inhibits the vagal afferent firing. Ghrelin increases appetite and is thought to be a short-term regulator of appetite. Ghrelin also suppresses insulin release. The vagus nerve is responsible for regulation of heart rate, respiration, digestion, and some reflexes like coughing and swallowing. It's really interesting. My youngest son has this like a chuffing cough that he has gotten for years. And we've gone down the path of food sensitivities and reflux and all sorts of things. And finally, when one of us was looking at the vagal nerve, we went, gosh, I wonder if it's stress. And so then we started having him, when we would hear him do this little chuffing cough, we would have him do the longer exhale than inhale. And sure enough, cough went away immediately. So the vagal nerve is really just amazing. So the gut brain, let's look at the broader picture now. We already discussed the bidirectional vagus nerve. The brain regulates the activity of the gut, and the gut regulates the activity of the brain. Neurotransmitters like serotonin and dopamine can be directly produced by gut microbes. Their metabolism is also heavily influenced by the microbes. The serotonin precursor tryptophan is driven away from that pathway and down the kynurenine pathway by bacteria. One of the ways this happens is via LPS, or lipopolysaccharides, and these are bacterial-produced endotoxins. They stimulate tryptophan to go down the kynurenine pathway, which is away from serotonin. The kynurenine pathway is inflammatory, and it can lead to things like elevations in quinolinic acid. Elevations in quinolinic acid have been shown to be increased in depression and have been implicated in a number of hormone-mediated cancers. Long and short chain fatty acids can directly stimulate the sympathetic, which is fight or flight pathways, predominantly via the peptide cholecystokinin, which is CCK. And while there are a number of different CCKs, the gut predominantly contains CCK33 and CCK22. Stress causes an increase in cortisol, which can lead to increased GI permeability and therefore increased inflammation. And then finally, BDNF, brain-derived neurotrophic factor. This binds to tyrosine kinase receptors. It plays a critical role in neuronal survival, synaptogenesis, and neuroplasticity. It's very drastically reduced in depression, and it's increased with things like exercise. Interestingly enough, it's also been linked to impulsivity and risk-taking behavior. This is a simplified visual to show some of the interactions we've been discussing, specifically focusing on chronic stress. So under chronic stress, cortisol is overproduced. However, it cannot exert its anti-inflammatory effects. As a result, cortisol's negative feedback on the HP axis is obstructed, resulting in hypercortisolemia. The excess of glucocorticoids inhibits immunologic activity, and it also increases threat sensitivity and negative mood. It impairs memory and other cognitive functions. We know the microbiome, gut, and brain talk to each other, so let's take a look at what can alter the gut microbiome. And basically, it's anything and everything, right? If you look at the list there, it's everything. Diet, stress, drugs, exercise, sleep, aging. Aging is a big one, and I'm going to take a little foray into that here in just a couple minutes. And as we know that the microbiome communicates with the brain via stimulating the immune system, vagus nerve, and the synthesis and metabolism of neurotransmitters, and via microbial metabolites like LPS, which is that bacterial endotoxin. So the regulation of the reward processes Thinking back to the slide on symptoms and comorbidities seen in depression, especially in younger patient populations, let's look at how the gut microbes may influence those. The gut microbes have the ability to produce substances that are very similar to those that our bodies produce. This is called molecular mimicry. We saw changes in appetite and changes in weight as a symptom or as a sign of depression. And Bacteroides produce molecules that are homologous to insulin, neuropeptide Y, which is a sympathetic co-transmitter, which stimulates food intake, especially carbohydrates, which delays satiety. And alpha melanocyte stimulating hormone, and this is anti-inflammatory and antipyretic. Short-chain fatty acids impact production and secretion of 5-HT, which in turn impacts the release of glucagon-like peptides, so GLP-1, and peptide YY, both of which are anorectic hormones. As a little bit of a side note, there have been a large number of studies showing gut microbial perturbations in anorexia nervosa, a population with a very high rate of depression. They show alterations in gut peptides, which alter both the homeostatic, which is the need for food as fuel to survive, as well as the hedonistic, which is the pleasure and the enjoyment that one gets from food, reward systems. So it's really interesting that microbia have the ability to impact both those reward systems. Methanobrevibacter smithii, which is most frequently associated with SIBO, has been strongly implicated in these studies. And also Streptococcus, Clostridium, and Bacteroides, all of these are considered commensals, but they drive an imbalance in short-chain fatty acid production. So we also see that social behaviors beyond eating are impacted by the gut microbiome's influence on hippocampal neurogenesis, alterations in the amygdala, and impacts on the oxytocin expression. BDNF, remember, it influences risk-taking behavior. And we also see that the gut microbiome's impact on signaling molecules. So for example, lacto and bifido secrete GABA, where Escherichia and Bacillus secrete norepi, and Bacillus and Ceriatia secrete dopamine. Gut microbes have the ability to secrete enzymes that deconjugate signaling molecules, changing the way sex hormones are conjugated, recirculated, and secreted. Again, looking at those issues we see in depressed patients, especially the younger patients, anger, disgust, self-blame, low confidence, etc., these seem like logical reactions to the alterations that we see here. This slide is a review. The only thing on this particular slide that we have not already discussed is the endocannabinoid system and the gut microbiome as it relates to depression and mood. The cannabinoid receptors are prevalent throughout the GI. You can see really good pictures of those on this slide. The top picture in the middle, and then the larger picture off on the right side. And what you see is that there are CB1 and CB2 receptors throughout all of the layers of the GI, and they communicate directly with the brain. This interaction primarily revolves around the gut microbiome-driven changes in intestinal permeability, which triggers systemic inflammatory tone, and that is regulated by endocannabinoid receptors. So LPS triggers both an immune response and production of endocannabinoids, and this can increase gut permeability, creating this vicious cycle. Again, because there's an aspect of immune system, this inflammation involved with depression, it's worth it for us to spend a little bit of time looking at that gut immune axis. So we know that the gut-associated lymphoid tissue, or GALT, 70% of the human immune system resides in the gut. The first line of defense in the GI is that mucus layer. It's produced by goblet cells, and it's a literal physical barrier to preventing host microbiota contact and translocation. The epithelial cells produce antimicrobial peptides. These are called ANTs, or AMPs. And then we have IgA specific for commensals produced with the help of the dendritic cells. And these are our antigen presenting and phagocytic cells. These interact with B and T cells and Peyer's patches, and they produce commensal derived antigens based on microbiota sampling. Literally go out into the lumen, grab a bug, take it back, show it to the immune system and say, friend or foe, do we like this? And then the immune system reacts. Short chain fatty acids, these guys do everything. They're produced by bacteria fermentation of indigestible or resistant carbohydrates, otherwise known as fiber. They create a hostile environment by lowering the pH. They have the ability to actually lower the virulence gene expression in microbes themselves. And especially butyrate, one of those short chain fatty acids, it regulates the size and function of the regulatory T cell network. So another way to say this is that short chain fatty acids regulate the cells that act to suppress the immune response. We have FOXP3 Treg cells. They suppress cells like NF-kappa beta. They maintain the peripheral and mucosal homeostasis by sensing the microbial products and metabolites. We have production of bacteriocins. These are short toxic peptides produced by specific bacteria to inhibit colonization and growth of other species. And then we also know that bile acids have antimicrobial properties as well. The conjugated primary bile acids are deconjugated to secondary bile acids in the colon by bacteria. These secondary bile acids are things like deoxycholic and lithocholic. And these secondary bile acids can be highly toxic to some bacteria, especially things like C. diff and Staph aureus. I want to take just a couple of minutes to talk about aging, especially given that 24% of women over the age of 60 are on antidepressants. So we can't have this conversation without first discussing what's considered elderly in the literature. And I'm only talking about what's considered elderly in the literature. It is a very hotly debated topic, even in the literature and especially in real life. So in general, those who are over 85 fall into the long-lived category, with centenarians in the extreme longevity bucket. Right around the age of 65, most studies will label adults elderly. So again, 24% of women over the age of 60, which would fall fairly squarely into the elderly population, are on antidepressants. And any stool test that you look at least any stool test worth its salt, will show you a diversity score. The studies consistently show healthy gut microbiome has a good degree of diversity. It's got a high diversity. And as the diversity decreases, the health of the gut microbiome and usually the health of the host decreases. We know microbial diversity decreases with age, as does the robustness of our immune system. And intestinal permeability also tends to increase, become more permeable with age. Inflammaging is the term that's gained in popularity recently, and we know that inflammation also increases as we age, with more and more research showing inflammation is the root of all evil, including depression. The microbiome modulates immune response and inflammation, so is it really any surprise that as these go awry, the diversity of our microbiome also decreases? So let's look at inflammaging a little bit more deeply just for a sec. The low-grade inflammation, or LGI, increases as we age. So again, studies looking at elderly as those over 65, we see consistently serum inflammatory markers elevated, things like interleukin-6, interleukin-1, TNF-alpha, CRP, HSCRP, and fibrinogen. There are a ton of studies that have shown that these markers are elevated in depression. The microbiome modulates our inflammatory response from a very early age. And some studies are showing that it actually begins in utero. The in utero environment is not sterile as once thought. And again, it's not surprising that as the microbiome shifts away from health, we as a human being do also. So we spent a good amount of time talking about microbiome, gut, brain, and depression. Let's take a look at clinical studies focusing on psychobiotics and the impact they can have on depression. So in general, there are a large number of studies done on psychobiotics, and they are predominantly preclinical. What that means is that they're predominantly animal studies, and especially germ-free mice. The clinical studies, or those done in humans, tend to be smaller. So the N values tend to be less than 100. There are some larger ones, but the large majority of them that are available right now are still relatively small. It was incredibly interesting to me to see that the vast majority of studies done on psychobiotics were performed outside of the United States. For the most part, the studies agree on mechanism of action for the major aspects of microbiome gut-brain interaction, meaning how the microbiome impacts brain and mood. Those mechanisms are all pretty consistent and widely agreed upon across studies. What is not agreed upon are the specific impacts that specific organisms have, with agreement trending in the higher classification, so meaning all species of lactobacillus do this one thing, or at the very, very specific classification. So lactobacillus casei W56 has this impact. So let's dive into some specific psychobiotic studies. In this study, patients were given multi-strain freeze-dried powder probiotic 7.5 billion CFU for 4 weeks. These were healthy individuals. They were not already diagnosed with depression. I really like this study because it has both objective, it has these fMRI findings, but it also has subjective with these questionnaires. And so the fMRI showed increased functional connectivity in the salient network. This network is responsible for attention, perception, and cognition. And then it showed a decreased functional connectivity in the default mode network. This particular network is responsible for things like distraction, rumination, impaired reasoning, and impaired decision-making. The questionnaires, questionnaires are our attempt to objectively report subjective things. So objectively reporting thoughts and feelings and such. PANAS questionnaire, which is a widely accepted questionnaire that's used a ton, it evaluates the positive and negative affect, one of the most commonly validated self-report measures of affect or emotions. So it lists an emotion: distressed, interested, proud, alert, irritable, etc., and then rates the frequency of the emotion felt over the past week, from slightly or not at all the way through to extremely. The scores are calculated for the positive emotions, and then separately they're calculated for the negative emotions. So you get scores for both negative and positive. In this particular study, the PANAS scores showed significant more positive affect after 4 weeks on the psychobiotic. It also showed a decrease in hopelessness and risk aversion. And, we don't mean risk aversion from like jumping off of buildings or something. What these studies, when they talk about risk aversion, what they mean is, I always think about it as kind of that person that sits alone in their house and they're afraid to go outside. They're afraid to talk to anybody. And they're just kind of like stuck in their own head and stuck in their own little world inside their head. It's decreasing that sort of risk aversion, helping them to re-engage with the world. This particular study was looking at psychobiotics and BDNF. Remember, BDNF is low in depression, and it's been associated with risk-taking behavior, right? Similar to what we just talked about on that previous study. And for me, the study was very interesting because it was psychobiotics used with patients who had already been on an antidepressant for a year. No other changes or interventions were done. So these were people who had major depression. So they had greater than 5 on the DSM-5 and had already been taking antidepressants. And what was seen was a significant increase in BDNF, and Beck's depression inventory dropped by 50%. And so Beck's, it's a self-assessment profile with questions like, I do not feel sad, I feel sad, I am sad all the time and I can't snap out of it, or I am so sad and unhappy that I can't stand it. So that type of question, you would get a score based on which one of those areas of sadness you related to. And they have questions like this for irritability, suicidality, pessimism, sleep, etc. A 50% reduction in that score is a huge shift in mental and emotional well-being, especially on people who had already been on antidepressants for a year. So this is Psychobiotics as adjunct therapy again. And this was looking at patients with moderate depression this time, and they were on this powder. And on all of these slides, the exact formulation is off on the side in the little chart. And it was 16 billion CFU with 100 milligrams of fructooligosaccharides, or FOS, once per day. They had been on fluoxetine for greater than 4 weeks prior to starting this psychobiotic, and no other interventions had been done. What was seen was a significant decrease in HAM-D. So HAM-D evaluates depression, HAM-A evaluates anxiety. However, what was also seen was that the intervention group did have a little bit of an increase in some GI symptoms like bloating and abdominal cramping. It's most likely due to the FOS in this particular formulation. It's a little bit of a side clinical note. I strongly prefer to dose prebiotics and probiotics separately. I find that I can hit therapeutic levels better with my probiotic that way. And I tend to focus on food as a source of fiber and prebiotics first, because it gets them to eat a healthier diet, and then come in with supplements for prebiotics second, only if they're needed. You can also dose these combo products at night before bed. That slight bloating and stuff, the patient will usually sleep through, so they don't have as much of an issue with it. This is looking at psychobiotic for SAD mood. This particular study was done again on a healthy population. They were on this particular formulation for 4 weeks at a 2.5 billion CFU dosage. Again, no other interventions were done. And this group was evaluated with the leads. So leads R specifically. So this is the lead-in index of depression sensitivity, and the R means it's revised. This particular questionnaire is used to assess vulnerability to depression. It is the one that is very frequently used in that healthy population. And it has questions like, when I feel sad, I often think that I can make no one happy. Or when I feel sad, I go out and do more pleasurable activities. Or when I feel down, I lose my temper more easily, right? It's getting at some of those less in your face type depression symptoms and things that people who are otherwise healthy might relate to a little bit better. So this particular study showed improvements in the scores, specifically around the areas of rumination, depressive thoughts, and aggressive thoughts. This study was done on depression and obesity. And it was done in normal weight obese, pre-obese, and obese women. A normal weight obese is a person who has a normal BMI. However, their body fat percent is very elevated. The powder that was tested contained 13.5 billion CFUs, and they were put on this for 3 weeks. There were no other interventions done. What was seen in this particular study was a decrease in BMI, waist to hip circumference decreased, total body fat went down, free fat mass, and the fecal transit time all went down. They also had significant improvements in body image, body uneasiness, and EDI-2. The depression in this specific study were very much related to their perception of their body and how others perceive their body and their amount of comfortable within their own skin. So this EDI-2, it's an eating disorder inventory questionnaire. It's very widely used in that particular industry. And it talks about things like perfectionism and distrust between people. Do you trust others? What is your awareness of your body? What is your impulse regulation? Do you have social insecurity based on how you look? So the fact that this was significantly improved is a big deal. There were no adverse events based on this particular therapy. No adverse event is huge, especially because one of the number one reasons people either do not take or stop taking their antidepressants is because of the laundry list of side effects that go along with those particular meds. So for people to have improvements and significant improvements with no adverse events is a big deal. We spent a fair amount of time talking about depression, microbiome, gut-brain interactions, and clinical applications of psychobiotics. Let's take just a few minutes to discuss how to pick a quality product so that you can have the most impact and educate your patient on why you recommend one product over another product. And I know that we all get those questions, and we want our patients to pick the one that's actually going to be useful, helpful, and have the impact that we say that these products are going to be able to do. So again, strain, right? I said at the very beginning of this that we would get back to what do we mean by characterization of strain? And the strain part, if you remember the studies that we just looked at in the chart on the side, the strain was usually it's a letter and a number after the genus and the species is listed. That's how you know there's a strain there. So characterization is ID based on biological, physiological, or molecular characteristics. And just again, for vocabulary's sake, 16S rRNA is PCR. Both 16S and whole genome shotgun are currently used to identify strains. And characterization tells us things like, will the microbe survive in high pH? What about low pH? What about with specific gastric secretions? It also tells us about actions. So will this particular organism modulate inflammation? What about lipids? What does it do for lipids? What about immune cell modulation? Does this particular strain have the ability to either directly kill or inhibit colonization of other microbes? And what products does this particular microbe create? And what are the balance of those products? Most of the studies that we saw today that showed a high degree of positive impact in depression and the associated other comorbidities of depression were multi-species, multi-strain formulas. And most of the literature, as we talked about at the very beginning, when they didn't see the large impacts or where the impacts were slightly skewed, were typically when they only used a single intervention instead of kind of a blended product. So this helps us understand a little about why that might be. You can't just put single probiotics that have been shown to positively impact a specific symptom in a bottle and call it good. They could potentially compete with each other and actually kill or inhibit the action of the others in the bottle. However, some combinations are actually additive and they have this really beautiful synergy. So studies looking at single strain supplementation versus multi-strain supplementation consistently show that there is a larger benefit from multi-species, multi-strain products. And the hypothesis behind this is this idea of quorum sensing. And quorum sensing, it's cell-to-cell communication, basically. And based on the product, the secretion and the detection of small signaling molecules given off by the microbes. These things can come together and be helpful, right? They're additive to each other. And now all of these microbes in this formulation have this synergistic additive effect, which enhances the efficacy of the product. Or they can be harmful, and it can actually trigger those bacteriocins we spoke about that inhibit or kill other microbes in the mix. And now your product does not work in the way in which you think it does. Just as an aside, if anybody wants to geek out on kind of a cool article, this particular article has some really fun examples of both aspects of this. So if anybody wants to be a geek like me, pop into that particular article. And so ultimately what this means is that the actual product in the bottle, it needs to be tested. That final formulation has to be tested to ensure that it achieves what the product says it does. And just throwing those individual strains in, you do not know how they're going to interact. You cannot guarantee outcomes without testing that formulation. So this is a little checklist cheat sheet for you to memorize, keep in the back of your head, whatever. And it's a summary of everything that I've said. So basically, you want a multi-species, multi-strain product. The product should have the strains listed that gets you to the targeted and very specific outcomes. There should be some indication of a third-party quality certification, like a CGMP or something, right? Everybody is quality control bodies. The supplement industry is no different. Having a label of them just gives you as a practitioner and wholesalers and patients a little bit of comfort knowing that some form of quality control and compliance control has been done. You, practitioner, need to do a little bit of lit search here. Do not take what the company tells you their product does as gospel. Go pop into the literature and just see what you can find. And the patient will be very happy that they know that their practitioner actually researches what they're giving them. So probiotics need to survive their journey to the shelf and their journey through the GI and still have metabolic activity, which means that at the end of their journey through the body, they are still doing what they claim to do way at the very beginning. And that should be done on the entire formulation. The companies out there, the large majority of them spend a lot of money on research, and they research their formulations. Call them, go to their website, look for literature, call them, email them, ask them for it. They want you to. They have spent a lot of time and effort on this. They want people to ask them. They're super excited to be like, oh, here you go. Here's a ton, right? And it's on their specific formulation. If a company cannot give you that, that should give you pause. So let's take just a minute and look at some very high level overviews of what we've spent this time talking about. The microbiome gut-brain axis has significant impacts way beyond mood, way beyond depression. Psychobiotics are promising for treatment in this disorder that doesn't always get really great results from other treatment options. However, there is still a lot to learn about manipulating the microbiome to target mood. And as Hippocrates said, 2,500 years ago, it all really does start in the gut. Thank you so much for your time and your attention today, and I hope you enjoy the rest of the conference.